Hi, my name is Aryan Shasta and my registration number is 20BCE0843. The topics I have chosen to explain are Intro to Nanomaterials and its physical properties. So what are nanomaterials? Nanomaterials can be defined as materials possessing at minimum one external dimension measuring 1 to 100 nanometer. In other words, all materials are composed of grains. The visibility of grain depends on their size. Conventional materials have grain varying in size from hundreds of microns to millimeters. The materials possessing grain size ranging from 1 to 100 nanometer are known as nanomaterials. Nanomaterials can be produced in different dimensionalities. One-dimensional nanomaterials such as surface coating and thin filming. Two-dimensional nanomaterials surface nanotubes, nanowires, biopolymers. Three-dimensional nanomaterials, nanoparticles, precipitates, colloids, quantum dots, etc. So now we will see what are the types of physical properties. There are basically four physical properties. First is optical property, second electrical property, third mechanical property, fourth magnetic property. So moving to the first property, that is optical property. One of the most fascinating and useful aspects of nanomaterials is their optical properties. It depends on parameters such as size, shape, surface characteristics, and other variables including doping and interaction with surrounding environments. Example of this is bulk gold appears yellow and nano-sized gold appears red. This is because the particles are so small that electrons are not free to move about, as in bulk gold. Because this movement is restricted, the particles react differently with light. So these are the applications based on optical properties: optical detector, laser, sensor, imaging, display, solar cells, biomedicines. Now the electrical properties. The electronic structure of nanomaterials is different from its bulk material. The density of energy states in the conduction band changes. Nano clusters of different sizes will have different electronic structures and different energy level separation. Now third, mechanical properties. As you can see in the graph, mechanical properties of nanomaterials are 1 or 2 order of magnitude higher than that of single crystal in bulk form. The enhancement in mechanical strength is simply due to the reduced probability of imperfection. Now the last property, magnetic property. Nanostructured materials are distinctly different from that of bulk materials. Ferromagnetism disappears and transfers to superparamagnetism in nanoscale due to huge surface energy. Surface atoms are not only different to bulk atoms, but they can also be modified by interaction with other chemical species. The magnetic moment of nanoparticles is found to be very less when compared to its bulk size. So this is a table of properties and applications of nanomaterials. So for optical light-based sensors for cancer diagnosis. Magnetic, increased density of storage media. Electronic, high performance and smaller components. Mechanical, improved new structural materials. So that is it for this topic. Thank you.